Okay, good evening, everyone. I am Priya. I'm one of the organizing committee co-chairs, and I welcome you all to IEEE Symposium on Data Analytics and Internet of Things. IEEE Victorian section presents this symposium in collaboration with Computational Intelligence Society, IoT Community, and University of Melbourne Student Branch. Just to quickly run you through the schedule of the symposium, it's going to run for 8 weeks until 19th of November, with events happening only on Tuesdays, Wednesdays, and Thursdays, either as afternoon or evening sessions. However, most of the sessions have been scheduled in the evenings. Since you're registered for the first week, you will be on our emailing list and will receive emails about the events scheduled for all of the following weeks. You can also follow our website and social media pages for more updates. So today, first, can I request all the panelists to mute their audios? Thank you. Today is the first tutorial talk on Internet of Things, which will cover introduction to IoT and its architecture. The talk will be for around 45 minutes with last 10 minutes dedicated for question and answer session. Please use the question answer tab at the bottom of the window to post your questions. And we have Dr. Sujan Chowdhury as the speaker for this event. He is currently working as a data scientist at Tech Connect IT Solutions, Gold Coast, Australia. He also works as a casual lecturer at Central Queensland University and has recently worked on a research project named Attack Detection and Mitigation on IoT with Deakin University. His interests include deep learning, image processing, big data, IoT, and data analytics to solve business problems. Thank you, Dr. Sujan, for joining us. The floor is all yours.
Oh, thank you for the nice introduction. And can you hear me? Is it all right? Okay.
Yes, you're audible.
Yeah.
And how about the slide? Is it visible?
Yes, it's all good.
Okay. Thanks, the organizer who and giving me opportunity to present some quick overview on IoT. My name is Sujan Chowdhury. I'm working as a data scientist in a Connect IT in a Gold Coast-based IT company, and we are mostly AWS partners. So my focus will be on AWS a little bit, how we can utilize the AWS or cloud platform to implement the IoT. So yeah, this is all about me. So this is a introductory session. So I'll try to cover what is the basic architecture of IoT, how it's changing in our everyday life, or how it's impacting, what's its future, why this is now a talk topic, and a very high level overview and some use case. Okay, so this is the title that I'm going to present throughout this session. And at the end of the session, if you have any question, happy to answer those questions. So my title is Introduction to the IoT and its Architecture. And I put a picture here to represent what is the IoT means in a gist. So I can say anything, any device, anyone, anybody, any service, any path, any network, any place, anywhere, and anytime, any context. So as we see, IoT will be the future, and from home to work, every day we are actually using lots of IoT application. Somehow people trying to, business try to try to implement some business outcome and solving some real world problem using the advanced technology of IoT. So if we see what you can do and what is some of the application, and we can say this will be our future driver in terms of any technological future. Okay. And if we will see IoT influencing in every part of our life, so you can, whenever you are going to work, your electricity or any household things that you are not using can automatically turn off. And while you are coming back to home, the music player, whatever the lovely music that you are interested to hear can be turned on automatically. Even while going to office, you can put some command and then it will make a nice coffee for you, and you can enjoy your coffee as soon as you reach the office. So this will be some of the cool future technology or already in place. So we are seeing the benefits of IoT. Okay, here is a little bit history about IoT and how it's growing. So this is definitely not a new things, and it's almost 40 years old. So that's why it's getting matured and people see value from it. If you see, the first IoT application was written by a programmer. They coded an application that could check the availability and temperature of the drink. And then from that, then if we started if we see the curve, by the end of 2020, the data is around 50 billion connected object in all over the world. And we are hoping it will grow up more and more in the upcoming years. It will be trillion. So the trend is quite high. So there are lots of opportunity here. And lots of cool technology will come in the coming years. So if I just simply say what is IoT, basically it's a network of connected device that interact and exchange information with each other. So any device that have the capability to share information between each other, that we can say as a part of IoT. So now the question is why there is so much interest and what problem actually we are solving. If we don't see any business problem and if we're not getting value from it, nobody will buy technology. And that is the two things whenever you are going to sell any technology. If people see value from it and it's actually solving some real world problem, then everyone will adopt the technology. That's how we see lots of new technology comes into the market and leading nowadays. So if we see from a IoT area, this is some of the area that I tried to cover, where actually we see so many applications. Like in healthcare, we see application of IoT. In smart infrastructure, we see the application of IoT. In smart home, we see the application of IoT. Agricultural sector, educational sector, in manufacturing sector, in smart grid, in retail. So all sector actually nowadays touching IoT. I will discuss some of the use case about that in an upcoming slide. But we'll see nowadays it's very much common in most of the house, like automatic watering, and it saves actually water. And also if it's raining, you don't need to watering automatically doing things. Even there are so many other technology available that sense whether how much water your plant needs. Based on that, actually watering only those plants. So this is possible because of the IoT or the sensors. So here's some of the use case that gets popularity with IoT in terms of healthcare. We see elderly people monitoring. So elderly people can wear some sensor and basically it's very difficult here to get people to observe all the time. And that's why they feel lonely. And if there is any emergency, anything, no one can respond. So by the help of IoT, if they fall down, we can detect the changes and it will automatically call to the emergency and call to the relatives or whoever put into that one, and then they can take immediate actions. So yeah, that's how it saves life-threatening and saves lots of life. Also, in terms of storing vaccines, medicines, using sensor, we can control the condition, temperature, whatever we need. So that the medicines they are maintaining the quality and not deterring the no need to throw any medicine, which saves lots of money for the business. In terms of smart infrastructure, we will see nowadays monitoring of parking space availability is quite difficult to monitor by person. So if we put in every place, if we put sensor, then it will be easy how many parking you have left and show an indicator that these are the available space. So we see that application in most of the supermarket nowadays. Another important use case that we see detection of waste levels in container to optimize the trash collection routes, which actually helping those infrastructure guy design the waste levels. We also work in actually working in some mining industry. So they have some heavy vehicles, and because there is no Google map there, so they use IoT sensor to draw the heat map or path of the route. Also, we develop some of the application like they have sensor, like in a gold mining company, they have a sensor attached with the device and continuously sending data to the cloud, and from there we do the reporting. They do some threshold. If it's go above, send alert to the relevant person. So that's how they are saving lots of money using the sensor. So which is also a cool and nice application. And we also see so many advanced technology in IoT on the smart home. You can remotely monitor your house using camera, surveillance camera or sensor. Whenever you go out, just turn on the sensor. If there is any intruder or try to break, it will automatically send alarm to you. So that's how you can secure your house. Also switching on and off remotely appliance for convenience to save energy. Even you can heating up or cooling down your house while you are coming to home. So using IoT sensor, you are getting that benefit. And also through voice, you can control now. For example, you can control your TV. You can turn on your TV. You can turn off your TV. Also, we can do shopping list using IoT device, and also music. So many sectors that actually touching in the terms of smartphone. So in retailing also we see lots of application of IoT. Like you can monitor the storage condition, product tracking for traceability purpose. Recently, we see some application like people go inside the superstore. You can talk about, you can select your specific product, then it will show a route that where actually the product located. So using the application of IoT, you can do that in retailing. Also analytical processing to track location of our activity duration. In terms of manufacturing and supply chain, predictive maintenance, real-time alarm, controlling of temperature, as I say, some of the example that we are using in the mining industry. Also, there are lots of use cases available nowadays. Like as I said, in the agriculture sector, smart farming, in the mining industry. Not only that, in the music industry. So many applications nowadays. So that's how it's the curve is going up and up in every year. So I'll try to show some from some. This is the application. I will try to utilize some of the IoT architecture, how actually it will design and how it will help you to do your use case. Okay. So this is the left side is the basic architecture, and this is an example how you utilize the architecture. So in terms of here, basically the sensor, actuator, or a smart device is the low level or the physical things that we have. Okay, so these are the sensor that are the key things, and they are very cheaper, but we are very sending valuable information that will help us. And we, after the sensor, we need some gateway that's actually help us to send information for the decision. Okay. So that, and after the gateway, we can use some cloud technology to capture all the information, so that is you can process it through some fastest technology. You can utilize the full power of cloud technology. And in the cloud gateway, we got the streaming data processor in terms of AWS. We got Kinesis and so many other services available there, which actually send us sensor data in data lake. So what is, it's like a data storage with security, with so many other policy. Okay. So from sensor, we get the data. You can store from there. We got the raw data. You can process the data, put into the format that you like. You are stored it in a tabular format, either in a SQL, RDBMS, or NoSQL format, any structure that you want. And from there, actually, then whatever the business logic that you want to apply to visualize your data at the end of the day, this is the final outcome that people will see. What is happening here doesn't matter for the end user sometimes, but from the technological perspective, we need to understand what is happening here, how to implement that. But most of the end user mostly see the outcome here. From here, we can do also some data analytics and for other decision, for other improvement, because you have now lots of data. You can do so many other business decisions. What are the other changes that people are looking for? Then you can update accordingly. Using that architecture or using the technology, we can use some machine learning. We can create our model, and then that's how we can control our application. So this is also a separate part, and also have adding lots of value by analyzing the data. Once you got the data, there are lots of other opportunity that you can play with. So here is an example of intelligent lighting. Basically, there are lots of sensors which actually sensing the daylight, sounds, people movement, so many. So there are different sensors. So if you are only looking for the daylight or other things, you can use only daylight sensor. If you want to track the sound, what is the sound quality on that area, what is the average sound, what time actually most sound, or you want to classify the sounds, you can collect sound sensor data. Also, you can to Serverless or some other sensor, you can collect the people's movement. So these are the sensors. It's actually get the data through a gateway in the data lake, and extracted information for the smart home dwellers gear and put into different format, like weak energy cost. So whatever from the raw data, whatever you want, we can put into here. From there, we do the analytics and present to the user. So these are the application. You can do some manual control using either mobile or automated, okay, using some command. So even for things, you can set some timer. Okay, after this time, okay, turn off the light. After this time, turn on the light. After this time, turn on the camera, so that your security is on. So many things that you can do by the use of IoT. So this is some basic architecture in terms of IoT. As I said, I'm working mostly on AWS service. So I hope all of you know that AWS is a leading cloud provider at this moment in the market, and competing compared to other cloud provider like Azure, Google platform, GCP, IBM, Alibaba, and so on. And yep, they are doing quite well in every sector, and they introduce all the different application in IoT service. So in terms of service, AWS put into 3 different formats. So in device software, this is the level where actually you are getting in, then you need to control your service, and then data service. So they provide service in terms of 3 things: device software, control service, and data service. So what actually the goal? So here, the goal is how actually I can connect my device and operate at the edge. So first of all, you need to connect your sensor to the gateway. That's I showed in the cloud gateway. Then how you can manage, control, and secure your device and secure your data. Okay. Once you got the data, how you can secure the things, how you're controlling this is discussed in this layer. And the final things, how you will extract the value from your data, or what is the business value that you can provide to your customer, like what are the applications, or what are the analytics, or what are the visuals that you can produce from the data service. So in terms of service, they have different name. Like in terms of device software, they have pre-RTOS and green gas. So there are slight difference between these two. Actually, pre-RTOS securely connect customer resources. Basically, this is sense and act. So they can sense the data from the sensor into the cloud, okay, and gather the data. Okay. And some green grass, they can take intelligent action locally. They can process everything locally, and also can give value directly from here. Okay, they don't need to go through the cloud. Okay, and this is very much popular in the mining industry, because in the mining industry, the connectivity is poor, and they don't have internet connectivity. They don't have much flexibility to send the data, and very slow. So this is very useful to them. Even when they got the connectivity, they can transfer the data there. Okay, so that's why this is getting popularity in the remote area, and very effectively using in the mining sector. So to connect and to talk with your sensor, there you need some SDK, some library. Everything is there. Different sensor, different library for Windows, for any other operating, for every operating system. They are available. So you just need to follow how you can incorporate that with your sensor. And once you got the data, then you need to control onboard here. And here actually we need to talk about the device security. So this is the layer where actually taking care of your data and making your things secure, and also doing some processing, analytic, and storing or warehousing everything. And this layer actually supporting the business things. Okay, and you can use any BI tool like Power BI, QuickSight, or Click, Tableau, any analytical tool or any app from here. Okay. And the good thing is there are all serverless. So, and if you know the meaning of serverless, that you don't need to pay upfront. So whatever you are using, you just need to pay for that, pay as you go. And other good thing about the serverless is scalable. Whenever your data is growing up, it will automatically adding resources. So you don't need to bother about the resource. So it's scalable, and it's very elasticity. And suddenly you need high performance, it will spin up machine for you. If you don't need it, it will automatically goes down. Using the advantage of cloud technology, actually making things easier for the customer. And yep, and people are quite heavily using all of those things to build their application. Here I tried to put a use case, which is popularly used in some of the manufacturing company, put into very high level 3 steps. So we can run Amazon free Aptos to securely collect data and connect to AWS IoT Greengrass enabled device. So assuming we don't have much in internet connectivity here, so we can use those service installed here and getting some data using the Greengrass, as you said, that can take run predictive model and can trigger alarm if there is any fault from here directly. And when we got the internet connectivity, that can send data for data analytics and upstream the data in the cloud, and then you can do the analytics and can take further decision when actually the machine change the state, what is the likelihood or what is the operating hour, and all the data will be collected using sensor here. And how long actually, or you can even using machine learning, you can predictive when will be the next things that it's going to trigger alarm. So you can take upfront decision and yep, do the things or change the devices before it goes down and impacting the overall production. Here is another important use case called AWS IoT for predictive maintenance. This is using all the AWS service. If you are not familiar with some of the service, maybe I'll quickly highlight some of them. So like it's a factory machine using a AWS Lambda, or we can say it's like a function. We can write some cloud function that can trigger the data to the AWS Greengrass to communicate with those sensors. And as soon as we got the data, we can interface with another Lambda or another function to talk with each other to create the model, and then send the data to IoT core or IoT analytics. Or from here, we can send some notification based on what's happened, like trigger or alarm. We can send email, SMS notification using AWS SNS or AWS email service. And finally, we can show it QuickSight. This is some of the BI tool like Power BI or other things that can visualize what's happening in there. Also, this is a machine learning platform, Amazon SageMaker, which can do some analytics, store your model, and can update model, and can do some automated things, automatic predictive maintenance. So they can automatically say, okay, this is the time that you need to do your maintenance, or showing some alarm, like some priority, like within upcoming 2-3 days, that's you need to maintain those service, or it's ready for servicing, and maybe do some priority, okay, and put into the sorting automatically. So that's how IoT can help with the predictive maintenance using AWS, power of AWS. Okay, so we talked a lot about, we see the basic architecture, we see lots of application, and it's growing. Okay, once everything, we see the good side, but of course, definitely once it's available and people see value, there are of course so many bad people around it to do the attack, like do some malfunctioning in your smart home, try to gather your data, try to send some false information, or try to destroy the thing. Okay, so nothing unless you take care about the security, then you can take the benefit. So that is very important one. That's how you can make sure your device is secure. So now security is a great concern in every in almost in every sector, and it's very important to secure the device. So whenever we are talking about security, it can happen in so many phases, because if we see the architecture, there are lots of layers, and there are lots of opportunity that security might compromise. So we need to think from that perspective, what are the threats and how you can mitigate. So I'll do some, of course, there will be dedicated session on that, dedicatedly talking about all the attack. I will just giving a quick overview, what are the layers IoT and what are the security mechanism that we can follow. That's it. So definitely they are following this pattern, like you need to do auditing, like validate IoT configuration is secure. So whenever you are getting the sensor data, first of all you need to audit the data, whether they are the valid data, valid sensor, whether anything is sacrificed or not, or whether you are getting actually flooding attack, sensor sending some DDoS attack or those type of things to exploit your devices, or maybe try to up your cost. So that is very important to do the audit. And then the next phase, we can do some continuously monitoring configuration to understand the security posture. So when you got the sensor data, you can monitor, you can analyze the traffic, and then try to understand some pattern from there. Even you can start incorporate some machine learning things, understanding the pattern, what should be the best case, if anything, sacrifice, how you can stop here, okay, without exploiting to the other things, or without presenting, or without triggering to the next command. Okay, so we can create some security dashboard in AWS. We have like CloudWatch, CloudTrail, that actually continuously logging what's happening. So in any point of time, you can, and they are presenting nicely in the dashboard. What are the CPU users? What are the memory users? What's happening? So everything is plotted nicely. You can go back time. You can select any time interval, anything. So that's what very important. And then the next thing is using machine learning and other things. You can think about the detect anomalies to device behavior. That is a huge scope and lots of learning opportunity there. Lots of research area, still people working how we can detect the anomalies, and how you can monitor the device behavior, and how you can detect the anomalies. And definitely when you detect, that's the next thing is to send alert, what or when you need to investigate to the relevant people, so that you can act before it create more damage. So that's also important to send alert. And then finally, how you can mitigate, or how quickly you can remediate those potential issues. Okay, so that's very important. If you see today, I think Microsoft Office was down for a few hours, and also Teams and all the things. Maybe it's a security attack, or it's maybe some changes they did during the weekend, and then crashes today. So yeah, but how quickly you can act, so that you can remediate your potential damage. So this is very important because our device, we are getting more used to it, and more dependent, and we are actually giving our personal data to the cloud. So security, we don't want to compromise. So it's very important area where you can work. In terms of IoT architecture, some people say it's a 3-layer, 4-layer, or 5-layer. If in 3-layer, we can the application layer, network layer, and perception layer. If it's in terms of 4-layer, we can split into application, network, support, and perception layer. In terms of 5-layer, it can be business, application, processing, transport, and perception layer. I will, in each layer, what are the things? That's what I will going to present now. So in application layer, so basically this is the application, all the layer, that's all the use cases, like the smart environment, smart grid, intelligent traffic, healthcare system, smart agriculture, food industry, environment production, industry monitor, intelligence processing. So all the application, so it's health, retail, all the application it will be here. So attack can be happen on this layer. They try to manipulate the data, manipulate your visual, or present the data which is fake. So yep, lots of things might happen here. In terms of network layer, we have, because we need connectivity, it can be happen through internet, mobile device, cloud computing, GPS. So possibility of attack on the network layer. Yep. And yep, so we need to take care on here. So in terms of networking, in terms of attack category, there are also so many other deep dive on in each layer. In terms of perception layer, these are the gateway that we showed, RPL, or LoRaWAN, RFID, Zigbee, all those devices. There is a possibility of attack here as well. And in sensing layer, we have the sensor in the low level, Wi-Fi, NFC, camera, all those sensing layer that's actually sending the data. So there might be security threat in this layer as well. So then we see there are lots of security attack. If we there are insider attack, there are outside attack. Even people will be one kind of attack as well. So yep, and we recently worked as with a in a project to detect some insider attack and apply machine learning technique on top of it to detect those attacks, understand the pattern, and then just detect the attack and mitigate so that we can stop the intruder to get the data from us. Yep, I think that's more or less from the IoT architecture perspective. Feel free to ask any question.
Thank you, Dr. Sujan, for the great talk. It was very informative, and I'm sure everyone found it interesting too. Now we open the floor to questions. Does anyone have any questions? Please, if you have it, please post it on the question answer tab. So we have the first question from Karina. Could you share a real example of successful implementation?
Okay, yep, I think that's a good question. If you see, sorry, I put some real example, or if you want in terms of demo, I haven't prepared any demo, or I have some demo. Actually, I'm not sure whether I can show it because of the I think the commitment with the company. But here is some use case. If you go to the AWS IoT use cases, you will see some real example, and there is demo from sensor, how they are getting the data, and in where they are storing, and how they are using it. So actually here are some of the real example. So for example, you would like to do intelligent lighting in your home. There are lots of sensors that you can buy from online or from store. And then if you go to if you follow the AWS architecture, then you have the sensor, you have the configuration, and you can pass the data through free actors to the AWS cloud. Okay, once you get the data, definitely then you can do the other action using some other function like Lambda or AWS function. So there are lots of demo and source code and everything available online. If you go to AWS IoT use cases, then yeah, I think it's also they have nice video to implement, and then you can do some implementation. So here is also some like a practical implementation that they did for predictive maintenance for a real industry. They have machine, and you write a method that's passed to the AWS IoT Greengrass, and then pass the data to IoT core and to visualize the data and do some predictive modeling to take earlier action. And other real example that I said, like a Newcrest mining company, they have some sensor known as the Pi. So they sensing all the autoclave, they say autoclave to produce gold. Then they checking the air temperature, they show the air oxygen level, everything through sensing the data. And through cloud, they're passing and storing the data. From there, we do some reporting, and the end users see what's happening. They can see the graph. If they set some threshold, if it's go pick up, they can do some real action, and they change the machine accordingly and getting value from it.
Thank you. We have the next question from Smith. In order to build a professional career in AWS architecture, does an individual need to really understand fully on how the routing happens in protocols such as RPL or ZigBee?
Sorry, what is the question? Can I see the question in the channel?
Yes, you can see the questions in question and answer tab.
Can you share some example? Okay, which one is the next? How can IT help us fight against? Okay, not that.
No, so in order to build a professional career, this one is from Smith.
Okay.
He wants to know if one needs to really understand fully on how the routing happens in protocols.
Okay, so there are lots of IoT cloud platform. If you are strict with, definitely their architecture or underneath the same. So first of all, definitely it's very useful if you understand the layer. Then you'll understand more. I think the basics is always important, and it will help you not to stick with one cloud. So you can move to Azure and other cloud, whoever giving you best outcome, right? So that's why understanding the layer is very important. But if you are just thinking to development without understanding anything, that's also possible if you understand only the AWS service, because they document it nicely, how you take your sensor, how you will incorporate your sensing data with their library, how you will pass it. You will see all those things happening one by one, and you can take one use case as an example. You will take your use case. Sometimes you need to mix up a couple of architecture and come up with your own idea and own design, right? Because you are not copying their architecture. You can do some changes. Okay, first of all, some things is very much common, like sensing, collecting data. So then whatever you are doing, that might be up to you. There are lots of other services that you can incorporate on this one. Also here, they didn't show security and other things. So then security layer will come, how you can make your data secure, like how you can create a virtual private cloud called VPC, how you can set the IAM role so that only people who actually you are allowing to see, they can see it. What are the end user will be? So there are so many other things will come. Yep. But my recommendation will be, yes, very important to understand the basics, and then it will next part will be easier for you.
Thank you. Just a quick thing. There are people who are asking about the PPT being shared. So due to privacy reasons, we cannot share the presentations of the speakers. However, the recording of this talk will get uploaded on IEEE Victorian Section YouTube channel. So please follow the YouTube channel of IEEE Victorian Section to view the presentation again if you want. So the next question is from Noor. How can IoT help us fight against COVID-19?
Okay, yeah, I think that also a good one. I think there should be application, okay. So first of all, yeah, recently I also worked in a medical datathon. So they actually doing this is a different things. They actually from detecting X-ray detecting the COVID patient or other patients. But how IoT will help you with the fight against COVID-19? I think here, for example, because we have a sensor, we have the data, and we have mobile devices, and we have now Bubble. So you can sense whatever within, you are going to a new place, you can see whether is there any COVID patient near to you, or how likely, or what is the possibility. So that's how it will help you to keep yourself safe, or to the community safe, using the IoT data or using the sensor information. And otherwise, in terms of practical fighting, if you are saying, I think vaccine, unless you get the, we contribute towards the vaccine, that will not definitely help. But yeah, there is opportunity here. We can build some application at least to mitigate the risk and stopping the community transmission. Or we can say, if you are not maintaining the 1.5 meter distance, just using sensor or something, creating some noise inside the store, or whatever public gathering. Yep, I think that's how we can fight at least to keep it safe and secure.
Thank you. The next question is from Zainab. In which layer does the cloned devices detected? Example, cloned RFID tag, cloned WSN, cloned Light Hub, and what mechanisms already implemented to provide either detection and prevention against cloning?
Okay, yep, I think, you are talking about the IoT layer. So you see those things, WSN, I think this is there, those cloning things is happening in the perception layer. So there are lots of security attack. If you see, there are lots of security attack at this moment available, and there are already some mitigation technique available. So for example, we did a combination of machine learning, like using SBM, using deep learning, and a couple of methods. We try to create, understand the pattern of the normal things, and then so you can train your machine in a normal without cloning, and and then train machine using different machine learning technique. You can see, you can do some research which one is actually applicable for your cases, and what are the attack data, how that pattern, like first of course, definitely is very important to understand the data, do some data analytics, and try to understand the pattern. And then you can apply a couple of machine learning, which one is perform better, or whether the combination is perform better. And that's how you can avoid the mitigation, prevention against the cloning.
Thank you. The next question is from Karina. Is AWS IoT Analytics capable of fault management, like real-time alarming, etc.?
Yep. As I said, I think we say also in from the analytics as well, you can trigger email message, you can trigger SMS message. It's already in place, and yep, you can do real time. And also you see here, you see an example using Greengrass. Also, they have the capability to do some analytics when there is no internet connectivity. They can trigger alarm to the manager as soon as there is an audit.
Thank you. The next question is from Money, I think. What is the price range of the sensors in Intelligent House, just as an example?
I think the sensor depends what type of sensor, because sensor, there are 1,000 lots of sensor. Like if it's a temperature sensor, maybe a couple of bucks, and depends what you are looking for. But sensor is very cheaper. So within 100, you get so many sensors. Sensor is not expensive, definitely, but the gateway and other things, but still that's shared. So you are paying based on the users.
Yep, thank you. The next one is from Sostarian. What are some best IoT platforms for a large steel corporation going to apply Industry 4.0 for the factory?
Yep. So at this moment, I think AWS giving cloud platform and Azure, Microsoft Azure, they are both competing in the IoT sector and giving lots of good services. So yep, with my experience, I also because some industry they sometimes biased with specific company, and they don't want to go or change the because some are Microsoft partners, some are AWS partners. So depends what they want. So Microsoft also giving good IoT platform, and I got opportunity to work with one of the mining industry called Evolution Mining. So they have some remote area, and they usually check the water level and on that, and they would like to implement using Microsoft Azure Stack IoT, and they are also giving we are giving I think nice architecture there. So yep, AWS and IoT is, at this moment is competing.
Thank you. Next one is a career-related question from Charlie about career in IoT. So to pursue a career in IoT, do I have to be proficient in all IoT layers?
Sorry, so what is the question? To be proficient in IoT?
To pursue a career in IoT,
Okay.
do I have to be proficient in all IoT layers?
Yeah, of course. The more you know, the more you that will beneficial for your career. But you can start with at least some of the basics. So of course, analytics, that is a different part. Analytics, you don't need to be expert on IoT. It can be any business user. So, but to understand this part, understand this one, I think if you are trying to build your career on the IoT, the bottom layer is very important. Okay, so that you can think about more application based. So, and whether you are trying to build your career in the security side, or whether you are building in the application side. So some people feel more interest on application development. If they see people using their application and they feel more comfortable. But some people feel, no, I will work only on the security. I like the networking things and other things. So based on what you want, definitely there are career opportunity in most of the layers. So this is a different layer, but if you are IoT specific, I feel the lower layer is very important, is the good one.
Thank you. There's one follow-up question from Zainab about, last question was about which layer does a clone device is detected. So the next question is, then the ML for the cloning detection can be in AWS Greengrass?
Yeah, you see here, but yeah, you need to build a model and deploy here, and then it will work with the Greengrass. So definitely to rebuild the model, you need computation power, right? So, so you need to build the machine model using AWS service, because you pass the data and it comes somehow in the here, and you need to retrain or whatever, and then you deploy it. So it can act or from here, not rebuilding the whole thing. So if your question is, or detection can be happen, but to recreate model, you need to use the benefit of cloud computing.
Thank you, Dr. Sujan. I think we will wrap up the session now. Thank you everyone for attending the first talk of the symposium and for all the interesting questions. For tomorrow, we have Dr. Farzad Khodadadi speaking on advancement of IoT technologies like IoT gateway and sensors. And then tomorrow's talk will be at 6 p.m. in the evening. So I look forward to seeing you tomorrow and to the upcoming events too. Thank you, take care and stay safe.
Thank you, cheers, bye.